Question 1. From the perspective of optimizing energy usage in a large manufacturing plant, Raymond, an HVACR technician, is tasked with evaluating whether to recommend a chilled water system or a variable refrigerant (VRF) system for a new extension of the facility. The extension operates 24/7, includes high heat loads from equipment, and requires zone-specific temperature control. Raymond must consider efficiency, scalability, maintenance feasibility over a 10-year operational horizon. Which system should he most likely recommend and why? A. Chilled water system, because it provides high flexibility for individual zones. BERF system, due to lower installation costs and improved efficiency in partial load conditions. C. ERF system, since it is ideal for handling large equipment heat loads in industrial settings. D. Chilled water system, as it handles high cooling loads better and integrates well in industrial scale central systems. Answer. Correct answer. D. Explanation. ERF systems are energy efficient and ideal for light commercial buildings, but they struggle with very high heat loads and simultaneous multi-zone demand in 24/7 heavy-use industrial settings. Chilled water systems offer better scalability and cooling capacity and allow centralized maintenance, which aligns with long-term energy and maintenance strategies. ASHRAE guidelines and DOE energy efficiency reports support chilled water systems for industrial applications with constant loads. Question 2. While examining a malfunctioning VFD control motor, Sabrina notices erratic amperage spikes. She measures voltage at the terminals and finds it fluctuating. The input power is stable, but downstream devices show irregular behavior. What is the most probable electrical issue? A. A failing thermistor causing erratic VFD response. B. Improper grounding or shielding of motor leads causing electrical noise. C. Overvoltage condition from the supply line. D. A failed VFD fan leading to overheating and current spikes. Answer. Correct answer. B. Explanation. In industrial VFD systems, electrical noise due to poor grounding or unshielded cables can cause erratic motor behavior and high-frequency interference. Proper bonding and grounding is critical per NEC Article 250 and manufacturer recommendations. Overvoltage would affect input, not just output, and a failed fan would cause thermal trips, not amperage fluctuation. Thermistor issues affect thermal protection, not voltage output. Question 3. Considering the evidence, a technician observes that the suction pressure is lower than normal and the superheat is excessively high, while the subcooling appears nominal. No restrictions are found in the liquid line. What is the most likely cause of the problem? A. Undercharged system. B. Fault compressor valve. C. Dirty condenser coil. D. Overcharged system. Answer. Correct answer. A. Explanation. High superheat with normal subcooling often indicates an undercharged system. With too little refrigerant, the evaporator does not get enough saturation, leading to excessive superheating. Subcooling may still appear normal if the liquid line has sufficient refrigerant near the metering device. This is supported by the EPA Section 608 Technician Certification Manual and HVAC Performance Diagnostics. Question 4. Under the assumption that Victor is preparing to service a refrigeration unit in an industrial setting, he begins recovering refrigerant. Midway through, he realizes his recovery cylinder exceeds 80% capacity, but the job needs to continue urgently. What should Victor do next? A. Continue recovery cautiously while monitoring cylinder pressure. B. Vent the remaining refrigerant since it's non-toxic type. C. Stop and switch to another recovery cylinder immediately. D. Lower the ambient temperature around the cylinder to maintain pressure. Answer. Correct answer. C. Explanation. Per EPA and OSHA 1910.101b, recovery cylinders must not be filled beyond 80% to prevent overpressurization and risk of explosion. Venting is strictly prohibited under the Clean Air Act. Manipulating ambient temperature to continue use is unsafe. Switching to another certified cylinder is the only compliant action. Question 5. Illustrated by a scenario where Ivan troubleshoots a three-phase motor that runs only briefly before tripping the overload relay. He verifies the current draw is balanced across all legs but consistently above the nameplate floor. What action should Ivan take first? A. Replace the motor with one rated for higher amperage. B. Reduce the mechanical load on the motor. C. Adjust the overload relay to a higher setting. D. Replace the contactor. Answer. Correct answer. B. Explanation. Overcurrent with balanced phases indicates excessive mechanical load. According to NEMA and NEC 430.32A1, overload devices must match nameplate ratings. Increasing the overload setting violates NEC and could cause insulation failure or fire. Proper troubleshooting begins with reducing load before hardware replacement. Question 6. During the process of integrating HVACR controls into a new BMS, technician Naomi observes that dampers are not responding to occupancy sensors despite proper wiring. The system software shows no fault codes and manual override works. What is the most probable root cause? A. Faulty actuator. B. Incorrect logic programming in the BMS. C. Bad occupancy sensor. D. Loose terminal connections. Answer. Correct answer. B. Explanation. In BMS systems, software logic often determines control behavior. If hardware works manually and no alarms are present, incorrect programming logic is a typical cause. Backnetic platforms rely on mapped conditions for control functions. ASHRAE Guideline 13 emphasizes validating sequence of operations during commissioning. Question 7. To illustrate this point, a technician working in a cleanroom calculates air properties using a psychrometric chart. The dry bulb temperature is 72 degrees and the wet bulb is 62 degrees. He determines that lowering relative humidity is essential to prevent condensation. Which adjustment is most appropriate? A. Decrease the supply air temperature. B. Increase the air velocity. C. Lower the dew point by increasing cooling coil efficiency. D. Add moisture to the supply airstream. Answer. Correct answer. C. Explanation. Lowering the dew point allows removal of more moisture, improving latent heat removal. Increasing velocity or temperature doesn't dehumidify air effectively. Per ASHRAE Handbook of Fundamentals, manipulating coil performance is critical method of RH control in precision environments like cleanrooms. Question 8. Taking into account the scheduled service for a large industrial AHU, technician Wesley is reviewing logbooks showing an upward trend in motor amperage and a drop in static pressure across filters. What maintenance action should he prioritize? A. Replace motor bearings. B. Lubricate the fan shaft. C. Replace air filters. D. Check VFD programming. Answer. Correct answer. C. Explanation. Increasing amperage and reduced pressure drop indicates filters are clogged, restricting airflow and overloading the fan motor. This causes energy inefficiency and potential motor failure. OSHA's 1910 maintenance protocols and manufacturer maintenance schedules prioritize filter replacement in such cases. Question 9. Given the circumstances, Julia notices that multiple thermostats connected to a single air handling unit are producing erratic zone temperatures. The zones are fighting each other and the AHU output fluctuates. What is the most probable system flaw? A. The sensors are installed too close to air diffusers. B. The control system is not using a proper averaging strategy for zones. C. The AHU is undersized for the space. D. The thermostats are set to different modes. Answer. Correct answer. B. Explanation. In multi-zone control, conflicting thermostat calls cause poor system performance unless averaged or prioritized via control logic. ASHRAE 55 and BMS design principles recommend weighted zone averaging or master zone designation to prevent system instability. Question 10. Contrary to popular belief, technician Diego suspects a refrigeration unit is short-cycling due to a low-pressure switch issue, but the actual cause is less obvious. The compressor runs briefly, then shuts off despite normal pressures. There is no evidence of moisture or refrigerant loss. What should Diego investigate next? A. Replace the expansion valve. B. Test the defrost timer for malfunction. C. Inspect the compressor contactor for intermittent failure. D. Evaluate the thermostat's location and calibration. Answer. Correct answer. D. Explanation. Poor thermostat placement. E.g. near a supply duct or window can cause rapid satisfaction of temperature, leading to short cycling Thermostat calibration and location should be verified before component replacement. Per CAN-DO guidelines, thermostat behavior is a common non-mechanical cause of short cycling. Question 11. In light of recent developments in energy optimization, technician Cordia is tasked with retrofitting an industrial HVAC system to improve heat recovery efficiency. She proposes using a plate heat exchanger to reclaim waste heat from the exhaust airstream and transfer it to the incoming fresh air. However, her supervisor questions the practicality due to concerns about thermal effectiveness in winter, which thermodynamic principle best supports. Claudia's proposal, the second law of thermodynamics enables heat to move naturally from cold to hot surfaces when driven by a fan. B. The first law of thermodynamics guarantees conservation of energy regardless of flow direction. C. The principle of sensible heat transfer allows energy recovery between air streams without mixing. D. Thermal conduction through metal plates cannot be effective at low ambient temperatures. Answer. Correct answer. C. Explanation. Sensible heat transfer through a plate heat exchanger allows for energy recovery by transferring heat from one airstream to another without mixing. ASHRAE Standard 90.1 promotes energy recovery ventilation for large buildings to reduce heating cooling loads. The second law describes directionality, not device function. Thermal conduction remains effective even in cold climates given the delta T and airflow design. Question 12. Through the lens of preventive diagnostics, technician Malik reviews a ladder diagram for a packaged rooftop unit. He notices that the compressor relay coil is not energizing, yet all safety switches are closed. Voltage is present at the line side of the relay, but not at the coil terminals. What should Malik check next? A. Replace the low pressure switch. B. Inspect for a broken common wire in the control circuit. C. Check the relay contacts for arcing. D. Measure capacitor capacitance. Answer. Correct answer. B. Explanation. If voltage is present on one terminal of the relay coil but not across it, the coil is not completing the circuit, often due to broken common. C. Wire or open neutral. Per neck and control circuit logic, coil requires both potential sides for energization. The contacts, switches, and capacitors would not prevent coil energization if the control voltage path is incomplete. Question 13. During the process of commissioning an HVACR system in a pharmaceutical cleanroom, technician Rachel observes that temperature and humidity are within spec, but airborne particle counts exceed limits despite new HEPA filters and positive pressurization. Which of the following is the most likely cause? A. Filter rack bypass due to improper gasket sealing. B. Exhaust fans operating at reduced capacity. C. Inaccurate dew-point control. D. Improper refrigerant charge affecting coil performance. Answer. Correct answer A. Explanation. In cleanroom HVACR systems, even tiny gaps in HEPA filter sealing can allow unfiltered air to bypass the filtration process. This leads to elevated particulate levels despite new filters. ASHRAE Standard 170 and ISO 14644 emphasize airtight filter mounting and frequent particle count validation. Exhaust fan issues affect pressure, not filtration integrity. Question 14. While examining a leaking suction line in a high-pressure R400 Tina system, technician Omar considers brazing the joint. However, the area is near flammable insulation and close to a sensitive VFD enclosure. What is the safest and most appropriate repair method in this case? A. Proceed with brazing while shielding the area with a fire blanket. B. Replace the entire section using press-fit mechanical joints. C. Use soft solder with a low flame temperature. D. Relocate the VFD panel and insulation temporarily, then braze. Answer. Correct answer. B. Explanation. Press-fit or mechanical joint technology. D. RLS zoom lock is an approved method that avoids flame and complies with NFPA 7-tie and OSHA 1910 subpart I. In locations with fire risk or electrical hazard, brazing is discouraged. Fire blankets may not offer sufficient protection. Soft solder is not compatible with R400 Tina due to high pressures. Question 15. By evaluating a programmable logic controller PLC setup, technician Elise finds the compressor cycles unpredictably. She observes that temperature sensors feed into the PLC, which in turn controls A relay to the compressor contactor. The set point logic seems correct. Which of the following is the most likely cause? A. Relay coil receiving intermittent signal due to voltage drop. B. Sensor calibration error causing false temperature readings. C. Faulty contactor sticking intermittently. D. Incorrect wiring of the pressure switch in the power circuit. Answer. Correct answer. B. Explanation. Sensor calibration errors in digital systems cause erratic behavior if the PLC interprets false inputs. According to ISA standards and ASHRAE control sequences, sensors must be regularly tested and matched to controller scaling logic. Relay or contactor issues would manifest differently, often resulting in failed or no operation. Question 16. With the advent of energy auditing software, technician Brian analyzes chiller logs and finds excessive cycling even during partial load conditions. The chilled water set point is stable and VFDS on pumps appear functional. What optimization strategy should be applied first? A. Lower the chilled water set point further to improve efficiency. B. Enable chiller lead lag rotation more frequently. C. Implement chilled water loop decoupling or buffering. D. Increase condenser water temperature. Answer. Correct answer. C. Explanation. Excessive cycling at partial load often indicates insufficient thermal buffering or loop decoupling. Decoupling stabilizes flow and reduces short cycling. ASHRAE energy efficiency guidelines and DOE audits recommend buffer tanks or decoupling piping for part load stability. Lead lag changes or set point shifts won't fix root cause. Question 17. A detailed analysis of IHVAC in a welding fabrication shop reveals elevated coal and metal particle concentrations during peak shifts. The space has a general exhaust system operating at 80% of design airflow. Which solution will most directly address the IHVAC issue? A. Install a rooftop economizer to increase fresh air intake. B. Upgrade to HEPA filtration at the air handler. C. Implement local exhaust ventilation (LEV) at welding stations. D. Increase exhaust fan horsepower by 20%. Answer. Correct answer. C. Explanation. LEV systems capture contaminants at the source, which is essential in industrial environments with fumes and particulates. General exhaust is often insufficient for hazardous material control. OSHA 1910.94 and IHT recommend LEV for welding operations. Economizers and HEPA filters don't capture heavy particles at the source. Question 18. Upon closer examination of a low-pressure centrifugal chiller's performance, technician Teresa observes that the evaporator temperature is dropping below design conditions, but cooling load hasn't changed. Gauge readings show low suction pressure and abnormally low superheat. What is the most likely cause? A. Expansion valve stuck open. B. Air trapped in the evaporator barrel. C. Low refrigerant charge. D. Faulty suction line thermistor. Answer. Correct answer. A. Explanation. An expansion valve stuck open causes too much refrigerant flow into the evaporator, leading to liquid floodback, low superheat, and dropping suction pressure. This can damage the compressor. High performance standards and manufacturer specs recommend immediate valve inspection in such conditions. Trapped air or sensor faults wouldn't cause this full symptom profile. Question 19. In a modern context of modular plant expansion, technician Lewis installs a new AHU and runs refrigerant piping. The line set includes several vertical risers and long horizontal runs. To ensure oil return and system longevity, he must choose the correct installation practice. What is the most critical consideration? A. Use of oversized piping to reduce pressure drop. B. Maintaining constant diameter in both suction and liquid lines. C. Correct pipe sizing and trap placement in vertical risers. D. Insulating only the suction line to minimize condensation. Answer. Correct answer. C. Explanation. Oil return in long line systems depends on proper pipe sizing and trap placement, especially in vertical risers. ASHRAE and IHT guidelines specify using riser traps at specific intervals to prevent oil logging. Oversizing and diameter uniformity can actually impair oil movement. Liquid line insulation is not critical for oil return. Question 20. The predominant theory suggests that R744 systems are increasingly used in high-efficiency refrigeration due to that. The technician Renee installs Cascade Co system and observes erratic high side pressures during moderate ambient conditions. What is the most likely solution to this challenge? A. Decrease evaporator fan speed. B. Install high-pressure receiver tank. C. Enable gas cooler bypass operation. D. Switch to synthetic blend refrigerant. Answer. Correct answer. C. Explanation. Co-systems operate in transcritical mode and require active gas cooler bypass or modulating controls to stabilize high side pressure, especially in fluctuating ambient temperatures. Per EPIT SNAP rules and manufacturer guidance, this is known issue with R744. Receiver tanks are used in subcritical systems only. Question 21. Throughout the course of a plant-wide audit, technician Andre notices that the HVAC system's night setback feature is frequently overridden, leading to unnecessary energy consumption. He proposes upgrading the BMS to integrate adaptive start and occupancy sensors. What is the primary advantage of this approach? A. It eliminates the need for manual thermostat control by maintenance staff. B. It ensures maximum equipment runtime during unoccupied hours. C. It reduces wear on equipment by maintaining constant operation. D. It dynamically adjusts runtime based on actual space use, improving energy efficiency. Answer. Correct answer. D. Explanation. Adaptive start and occupancy sensors allow HVAC systems to precondition spaces just in time for use and avoid conditioning during unoccupied periods, aligning with ASHRAE 90.1 and lead energy efficiency guidelines. Manual control A is too reactive and options B and C contradict energy-saving objectives. Question 22. In what ways can a high suction pressure and low discharge pressure on a reciprocating compressor be interpreted during a service call? Technician Lee observes these symptoms along with warm air discharge and low amp draw. Which of the following best explains the cause? A. The condenser fan is not operational, causing reduced heat rejection. B. The system is overcharged, leading to inefficient compression. C. The metering device is restricted, limiting refrigerant flow. D. The compressor has internal valve damage, reducing compression ratio. Answer. Correct answer. D. Explanation. Internal compressor valve failure leads to re-expansion of refrigerant inside the cylinder, reducing discharge pressure and raising suction pressure, according to RE diagnostics. This symptom combo, warm air, low amps, poor compression, is classic for mechanical compressor failure, not metering or fan issues. Question 23. From a practical standpoint, why superheat a critical measurement during refrigeration system charging and troubleshooting? Which of the following best explains its importance? A. It shows whether the compressor is short-cycling due to low pressure. B. It verifies that refrigerant vapor is fully saturated before entering the compressor. C. It ensures refrigerant is fully vaporized, preventing liquid slugging at the compressor. D. It prevents subcooling from occurring, which would damage the TSE. Answer. Correct answer. C. Explanation. Superheat is the temperature increase above the saturation point of refrigerant vapor. It confirms full vaporization before reaching the compressor, which prevents damaging liquid slugging. Per EPA Section 608 in manufacturer guidelines, it is essential for system safety and efficiency. Options. And D. Misunderstand superheat's function. Question 24. To determine whether technician Sophia can legally top off an R22 system with a blend refrigerant, she consults EPA guidelines. The system has a minor leak and the client has requested a quick repair. What should Sophia do next there? Add the R22 substitute refrigerant to maintain cooling levels. B. Recover remaining R22, evacuate the system and recharge with the approved substitute. C. Top off with R400 Tina since it's more efficient. D. Add POL to the system and introduce the blended refrigerant. Answer. Correct answer. B. Explanation. EPA regulations prohibit mixing refrigerants. The proper method is full recovery of existing R22 evacuation and recharging with a compatible substitute. Topping off or mixing a CD violates EPA Section 608 and can damage components due to differing oil compatibility and pressures. Question 25. From multiple perspectives, industrial HVAC installer Tylo is placing rooftop units ATAS on a facility expansion. He wants to minimize refrigerant line lengths and avoid oil return issues while maintaining access for service. Which placement strategy best meets these requirements? A. Install ATAS close to the edge of the roof for drainage. B. Place units directly above served zones, minimizing line length. C. Space ATAS evenly across the roof for airflow balance. D. Cluster ATAS near electrical panels to ease conduit runs. Answer. Correct answer. B. Explanation. Minimizing refrigerant line length reduces pressure drop and supports oil return, especially in long line applications. ASHRAE and OEM installation guidelines recommend placing equipment as close to evaporators as possible while allowing access. Rooftop layout for drainage or panel access is secondary to performance. Question 26. Examining the consequences of a control system failure, technician Nora finds the economizer damper on. A large Yahoo stuck in the open position. The system is pulling in hot outdoor air, but the BMS shows the damper is closed. What is the most appropriate first step in resolving the issue? A. Replace the damper actuator immediately. B. Reprogram the BMS to close the damper using override mode. C. Verify the feedback signal from the damper position sensor. D. Disconnect power to the actuator to reset the position. Answer. Correct answer. C. Explanation. BMS relies on feedback from position sensors to control actuators. If the damper is open but reported as closed, the feedback signal may be faulty or misconfigured. Per ASHRAE Guideline 13 and Building Automation Practices, verifying signal integrity should precede any hardware replacement or override. Question 27. Contrary to popular belief, not all industrial evaporators operate the same way. Technician Greg installs a flooded evaporator in a process cooling system and observes occasional refrigerant carryover into the compressor. What key components should be added to prevent this? A. A suction line accumulator. B. A liquid line solenoid. C. An oil separator. D. A surge drum or separator before the compressor. Answer. Correct answer. D. Explanation. Flooded evaporators require a surge drum or refrigerant separator to prevent liquid carryover, which can damage compressors. Unlike DX systems, flooded systems are prone to overfeeding. ASHRAE system design, manual, and equipment manufacturers require this safeguard for safe operation. Question 20. The core principles of OSHA electrical safety require lockout tagout before service. Technician ME is assigned to replace a contactor in a live control panel due to production urgency. Her supervisor insists on a hot work. What must Mia do to remain OSHA compliant? A. Proceed if insulated tools and PPE are used. B. Refuse the task and report it to the safety officer. C. Turn off only the control voltage and work carefully. D. Wear a face shield and rubber gloves for protection. Answer. Correct answer. B. Explanation. OSHA 1910.333 mandates denegization and LOTO for electrical service unless absolutely necessary and documented. Working energized due to emergency is not acceptable. Refusing unsafe work is protected by OSHA's General Duty Clause. PPE does not remove the requirement to denegize. Question 29. As evidenced by increased occupant complaints in a facility with automated controls, technician Harold investigates why zones are simultaneously heating and cooling. He finds that both hot water and chilled water valves are modulating. What is the most likely cause? A. Valve actuators are installed in reverse. B. Sensors are located too close to return air grills. C. Control sequences do not include deadband between heating and cooling. D. Pumps are running continuously, confusing the BMS. Answer. Correct answer. C. Explanation. Without a control deadband, heating and cooling can be called at the same set point, leading to energy waste and comfort issues. ASHRAE Guideline 36 recommends a minimum deadband, often 5 deg, to avoid simultaneous operation. Valve polarity or sensor location may affect performance, but deadband logic is the core issue. Question 30. While it is true that low voltage can cause motor overheating, technician James discovers a A three-phase fan motor drawing normal amperage but overheating rapidly. Voltages are balanced and within 2%. Which fault could be causing this? A. High ambient temperature at the motor. B. Open winding on the motor causing single phasing. C. Weak capacitor on the start winding. D. Incorrect motor tap selection for voltage supply. Answer. Correct answer. D. Explanation. On multi-voltage motors, selecting the wrong voltage tap e.g. wired for 280 V at the 240 system causes overexcitation and overheating even with balanced amps. NEC and NEMA motor installation standards emphasize proper tap configuration. Options B and C would result in higher current draw or fail at starting.